the best practices you should follow in microservice. Okay, then we will go ahead with the manual cluster creation method. Okay, so the first thing we are going to talk about is called, so the first thing which we already highlighted. Okay, and when you want to design a microservice, okay, it should be a full stack application. Okay, that means it should have the UI layer and it should have the business logic layer if needed, and also it should have its separate database. That is the best way to have a better microservice scenario. Okay, so it should be built around the business technology. We have discussed about this a lot. So it should be the ideal scenario of a better microservice. Okay, if one microservice want to receive data from another service, it should be via the UI layer of the microservice, not sharing the data from the database. This should be the best approach. Okay, and next is, whenever you are using, or is there any SaaS availability, okay, software as a service availability, go ahead and use them. Like for example, in the diagram which is shown in that picture, where we have a Kubernetes cluster. In Kubernetes, you can control the access control of the peoples who can communicate using role-based access control mechanism. We'll go in detail when we put up our dashboard, Kubernetes dashboard and things. We'll talk about that in detail. Okay. In that case, instead of managing the access control in the role-based access control, it is integrated via the Azure AD. So normally if the application is hosted in Azure, they will have the Azure AD to manage the user access control, and you can use the similar thing on the Azure AD. Okay, and when you want to push and pull images, use the SaaS solution called Azure Container Registry to store and load the images. And in this architecture, they are using Azure Pipeline for the CI/CD functionality to use that. So take advantage of all the SaaS solutions available in the cluster, so that you don't need to work lots of manual things around. Okay, this is one of the best practice. So use the SaaS solution as much as possible to avoid any manual works. Okay. And the best practice of Kubernetes has been divided into 5 major components. I have divided them. One is, what are all the best practices you should follow while building the containers? And next is the container internals. That is, when you're passing information to the container, or when you're running a process inside the container, how to run it. So that is on the container internals. And what should be the best practice you should follow when you're doing the deployment of microservices? And also, when you are exposing a service, what are the best service you should follow? And then what should be the ideal or a best practice for a application architecture? So let's talk one by one. First, while building the containers, don't use the images from the internet. Okay, try to use the official images. Okay, don't try to use images from the internet which is not from official source. Okay, because you don't know what are the other components they have put into it, or otherwise they might have some images, or they might have used some libraries which is having some vulnerability which you may not aware of it. Okay, so always use the official image, or otherwise build it from the scratch. Okay, and then next is, keep the images as small as possible. Okay, we have used the multi-stage build. Okay, in Docker we have talked about how to do a multi-stage build. Okay, use that mechanism to keep the images as small as possible. Okay, and then use the builder pattern. Okay, that means, so basically you do a build of the application outside of the actual application container, and once the application images, or the binary image is created, just copy the binary images into the container and host it. Okay, don't keep the build source code into the container, or don't do those kind of steps here. Okay, so this is the use the builder pattern. Okay, and next is the container internals best practice. Okay, always run the application as a non-root user. So we have talked about the user directive in Docker. So whenever you are building a container, try to build it as a non-root user, because the default user for the containers is root. Don't try to use that. And then make the file system read only. So whenever you are running a container, if you want to mount a file system, okay, which you will not be writing anything into it, make it as a read-only file system. Also, when you run a container, okay, when you don't write much of a data inside the root, always make the read-only file system true option. Okay, and next is one process per container, which we already talked in the 12-factor app development principle. Always run only one process per container so that the process health can be mapped to the container health. Okay, and next is don't restart the failed containers. Okay, if a container is failed or if you want to do some changes, stop the container and then bring the fresh container from the image. Okay, and then write the log files on the standard output and standard error. Please do not write into the file inside the container, so that you will not be able to collect the missing data. So these are all the best practices for the container internals. Run the application as a non-root user, mount the read-only file system as read-only, and run only one process per container, and do not restart the container, and then log everything to the std out and std error. Okay, and next option is what are the best practices to follow in the deployment. Okay, so while going in the deployment, we'll talk about that in detail, but I will give a hint. So Kubernetes can maintain the history of the deployment. Like, let's say today I'm going to do a deployment. Okay, so the next week I have a planned deployment. Okay, I am doing the deployment next week. At that time I had some issue. If I want to roll back to the previous version, Kubernetes allows you to do that. Okay, so it stores the deployment history for a specific period of time. Okay, not a time, it is based on the number of deployments. We'll see that in detail. So whenever you do a deployment, give the reason for the deployment, so that when you want to roll back to a previous version, it will be easy for you to track to a particular version and go to that particular version. So that is what, use the record option for easier rollbacks, right? So whenever you do a deployment, record the reason for the deployment. I will show you how to record that when we go into the lab. So always do the deployment with the record option. Okay, and next is use as much as label possible, because when I talked about the Kubernetes component, I talked about labels. Labels are very important, I told you at the time. So use the labels as much as possible, like what is the environment it belongs to, what is the application it belongs to, inside that what is that service. So provide as much as labels possible. And next is use the sidecar proxies and watchers, etc. So I told you, like, sidecars are used to offload major works done by the actual container, right? Use the sidecars as much as possible. Okay, and then do not use sidecars for bootstrapping. Okay, sidecars can be also used to get the container ready for the service to bring up, but that is not a best approach. Do use the sidecar for bootstrapping the image, and then always use a proper tagging for the image. The reason being it is, if you use a latest tag or a no tag literally represents the latest tag. Imagine you are deploying the container on a Kubernetes cluster, okay? And let's say you have mentioned as latest, okay? In your container registry, you may have a latest image, but there is already a latest image available on the node. It will not pull the latest image. It will try to use the image on the local node, which is there, okay? So always don't use the latest tag or use the images without any tags, okay? It's always best to mention a tag. The best practice, what I would suggest is, you will be using a continuous integration system, right? Continuous integration systems will have a build number, okay? So always whenever there is a build happening and it is pushing, put the build number as a tag to the image, so that the particular build number will be pushed onto the container registry, okay? So don't use latest tag or no tag. Okay. And use the readiness probe and liveliness probe. Okay. So in Kubernetes, there are two concepts called readiness probe and liveliness probe. That means when a service is coming up, it may not be come up immediately when the container comes up. It may have some internal process. It has to run it only after some particular time it will become ready, right? So that is, you can define it in the readiness probe. So that is, you can just browse a URL, and once the container is ready, it is going to give you a 200 message. Then you can use that as a readiness probe. Use a readiness probe to ensure that then only the container will be added to the load balancer. In the same way, configure the liveness probe of the container. That means this is where you are telling Kubernetes when you can consider this container as inhealthy. Like for example, the container is in the running state, but the container is not responding to a request on the particular port number. Then you can, this is how you configure the liveness probe. So the container has to respond to a particular port number for a HTTP request. In that case, if the container is not responding, you can consider that as a failure one. So always use readiness and liveliness probe. These are all the best practices you should follow in a deployment. Let me repeat. Record the cost for the deployment. Use plenty of labels. Use proxies and sidecars. And then don't use sidecars for bootstrapping. And don't use latest tag. And do not use, always use readiness and liveliness probe. Okay. So these are all the advantages. And next options are in the service. So whenever you are doing a deployment, I told you will create a deployment. After that, the deployment will be mapped with the service. Okay. Always create the service first, then create the deployment. The reason behind it is, so when you create a service, the service will be available in the Kubernetes. Whenever the container is coming, Kubernetes is going to inject some of the environment variables. Okay. So when the service is already up, that service name will be available in the container. So always first bring the service up, then bring the deployment. Okay. And then the next point is up to you, because when you use a load balancer, okay, it is going to create a load balancer in your cloud provider. For example, in Amazon, if you use the type as load balancer, it is going to create a load balancer. Every load balancer, they are going to charge you 25 cents for it. Okay. And also the traffic which is going via the load balancer, they are going to charge for you. So you need to pay for that. Based on your requirement, you can decide whether to use the load balancer in an extensive way or a different way. Okay. And next is map external service to the internal ones. So whenever you want to expose a service, first expose this as an internal service, then expose it to the external. So that way you will make it better. Okay. And the next is in the application or architecture, use Helm chart. Helm is a package manager for Kubernetes. So the advantage over Helm is you don't need to write the complete deployment YAML. You have to just give some parameters, so that will bring up the complete application. Okay. So use Helm chart. We are going to see a detailed lamp of Helm. Okay, we'll use it. And then don't clearly mention the dependencies in logic. Okay, it's better you use a service mesh like istio or linkerd. Okay, and then make sure your microservices are into micro. That means, imagine if you are creating a microservice and don't decompose it to function level. Like the typical example I would say is, if you are creating a microservice for user management, that is well and fine. Don't create a microservice for a password reset, right? So password reset is just a function in the user management. It is not a separate microservice. Don't create your microservice that is like very less. Okay. And then use namespaces to split your cluster. So have a use the namespace effectively. Okay. I have seen customers using separate names for namespace for separate applications, or even, as I told you, customer wise also you can use namespaces, and effectively use the role-based access control. Don't give all the permission to all the users. If they are particular to a namespace, give them access only to the particular namespace. So these are all the best practices of the